Alright guys, so today's video for class is going to be focusing on the area of parallelograms and trapezoids, and so our objective by the end of this is to be able to find the area of parallelograms and trapezoids. So it's important to know what a parallelogram and a trapezoid are, so let's go over some definitions. Here you see a picture of a parallelogram, and this one will actually be called A, B, C, D. And you notice that when I named it, I kind of went around the horn there. I don't want to skip back and forth and say A, B, C, D. They want to be named sequentially. So we're going to call that one A, B, C, D. And so a parallelogram is a quadrilateral, which again might be another vocab word for you, but it means a polygon with four sides. So a four-sided polygon in which both pairs of opposite sides are parallel. And by opposite sides, I mean they are across from one another on the polygon. And so if I'm looking at that, I notice that AB is parallel to CD. So here's our line segment AB, parallel to line segment or side CD. Those are parallel because they will never cross, intersect, or touch each other. We should also notice that sides BC and AD are also parallel because they will also never intersect, cross, or touch. We also want to be aware that a rectangle is a special kind of parallelogram because it has four right angles, 1, 2, 3, 4, but it's still a parallelogram because this side and this side are parallel, and also the top and bottom bases are parallel as well, making it a parallelogram. Now, trapezoids are slightly different. So in this one, we can see that if we have, let's say, R, S, T, U. Alright, so if I'm looking here, I've got two sides that are parallel, okay? So I've got my ST and RU parallel. But I should see that RS and TU are not parallel because somewhere up here they would intersect with each other. And so one pair of sides is parallel, the other pair of sides is not. So parallelogram, trapezoid. All right, and don't forget to pause if you need to copy down these definitions. All right, so now it's time to take a look at the formulas for the parallelogram and the trapezoid. On this first one, you will see that the area is very similar to both the rectangular and triangle formula. The area is base times height for a parallelogram, very similar to a rectangle. And that's because you might be thinking a rectangle is a parallelogram, and you'd be correct. So same thing as length times width here, but in this case, we don't want to go by the diagonal. We're actually going to have to drop an altitude or draw an altitude there if it doesn't have one. So the base is going to be this polygon, or the side of the polygon here, and the H, the altitude, is the one that's perpendicular to that base. And that's why we have that little square there, seeing that these are 90-degree angles. They are perpendicular to each other. And so to find the area of a parallelogram, we use A equals base times height, or B times H. The trapezoid is a little bit trickier because you notice it's kind of like B times H, but we have this kind of confusing piece over here. That's because we have two different size bases on a trapezoid. We have this little one up top, A, and we got the big one down here, B. And so what we can do, though, is take the average of these two. And to do that, we add them together and divide by 2. So A plus B divided by 2 will give us that average base, and then we still multiply it by the height, very similar to the parallelogram and the rectangle. The other way to do it would be to say the height times the quantity of A plus B over 2. All right, I am preferential to this first one here, so that's what I'm going to use for the purpose of this class. So the first thing we're going to do, add the two bases together, divide them by 2 to get their average, and then multiply it by the height. If you need to copy these, pause the video and do so. Because now you're actually going to find the height of this parallelogram in the first one. So number one, we're going to find the area of the parallelogram, and so I'm going to pause the video here and allow you to do that. Alright, so hopefully you were able to answer and use this formula saying that 6 centimeters times 4 centimeters is going to give us A equals numbers first, 24, units last, centimeters, but not just centimeters, since we have two of them, centimeters squared. All right, and that's our final answer. Area equals 24 centimeters squared. Now what I'd like you to do is go ahead through and do number 2, which is to find the area of the trapezoid. And so I will give you a second to do that. All right, so hopefully you guys plugged in the values and you said, well, I see that A is 6 centimeters and that B is 8 centimeters. And I'm going to divide that by 2 and multiply it all by the height of 4, which was given to us in this case. Won't always be given to us. All right, so now we're just going to go through and do some simplifying. A equals, if I'm working inside parentheses first, I'm going to get 14 centimeters. We don't need a square on this one because we're adding, not multiplying. So 14 centimeters over 2 times 4. And that should have a centimeters on it there, so we'll add that. If we continue to simplify, we see that 14 centimeters divided by 2 is going to give us 7 centimeters times 4 centimeters. And if we go to simplify that, we see that if we multiply numbers, 7 times 4 gets us 28, and centimeters squared. All right, so now I want you guys to draw a right triangle with one angle equal to 50 degrees. And to do that, you're going to need to take out your trusty protractor. And so here's mine on the screen. And so one of the things we want to do is figure out how to use this. And it's going to be a little different for me because I have it on the screen, and a little different for you because you guys have them in your kits. And so what we're going to do, I'll show you how I do this. This little crosshair right here should always be at the vertex of the angle we're measuring. So since I'm working on a 55-degree angle, I'm going to 55, and you'll see that I'm putting a dot there. And I'm also going to want a dot at right there at the crosshair. All right. And so now once I know that this is a 55-degree angle, and you know that because you watched the video in the beginning saying that we measure from this, so we're going to use 55 that way. I'm going to actually, now that I have it, I can move my protractor out of the way. You guys are welcome to keep yours there. But I see that I'm actually going to have, and I'm going to cheat and use the line tool. You guys can use a ruler if you want a straight line. That triangle tool in there is going to help. If I draw that angle and connect it, I know that that is 55 degrees. And hopefully if I put it back over, I will see that I have measured it nicely, 55 degrees. Excellent. So I also know that that means that this line must have gone this way. And since it's a right triangle, I know that I should be forming a 90-degree angle, and that'll be this one that we drop here. And we also want to show by drawing a little square here that it is in fact a right triangle. And you might want to even put a little thing in here saying, hey, this is 55 degrees. And because of that, we should also change this to 55. Should have said 55. I wrote the wrong number up there. All right, so 55 degrees here, and we measured it. We know that that one's 90, so hopefully you'd be able to figure out what that angle is. But that's how you use a protractor. And if the same thing as if we wanted to measure it. So if I wanted to know what that other angle was, I could just rotate my protractor. And since it's opening up this way, I'm going to use the top numbers now. I'm able to see that this angle is actually going to be 35 degrees. So if you wanted to, go ahead and write in that is 35 degrees. If you can't figure out how to use this tool, let me know and I will be over to help you. Alright, so I'm going to get rid of this and have you guys copy down this vocab word. It's ratio. We're going to need that for the next little bit that we're going to do. And a ratio is a comparison of two things with the same units, often in fraction form. So the example here I'm going to show you is if we read this as the ratio of A to B, it would look like this, A over B, or A to B. So don't forget to pause this and copy it down if you need it. Alright, so finally here we've got a right triangle. We see that angle B is equal to 37 degrees, and we see that the sides have certain values. Okay? And so if it says find the ratios of the sides, that means find the comparison of these numbers. So I'm going to work with this first one first. I see side BC, which is 3 inches, over, or 2, A to B. And the A to B side is 5 inches. Now, we know this is a fraction. Inches will actually cancel out here. Okay? And so I have 3/5, and if I wanted to put that in decimal form, 3 divided by 5, 0.6. So on this next one, I've got A to C, which is 4 inches. And I've got A to B, which is 5 inches. And I'm not going to finish this one for you guys. I want you to get it into decimal form and put that answer in your quiz question. Alright, so hopefully you were able to see that 4 over 5 inches cancel is going to get us 0.8. And then so we will take a look at number 3 here, and I'm not going to help you guys at all with that one. I want you to do that one all by yourself. Alright, so hopefully when you did B to C, you said that was 3 inches, going by this, and the AC is 4 inches. Alright, and so that is going to give us 0.75. Alright, and that's how you find the ratios. Now, if you have a little bit of time and you want to watch the rest of this video, I'm just going to go over some terminology. And so one of those things is going to be, if I'm looking at angle B, okay, so angle B is going to be the angle I'm considering. I want to be able to name these sides here. And so what I'm going to say is that this side BC, since it connects to angle B, that is going to be our adjacent side. And since AC is over here, that's going to be my opposite side. And finally, since this is a right angle, we are looking at this. That's going to be my hypotenuse. Alright, so adjacent, opposite, and hypotenuse. Now, if I were, for example, no longer considering angle B, okay? So say I want to now consider angle A. We'll write that feedback in there. If I'm considering angle A, when I'm talking about my adjacent side, that's going to be the non-hypotenuse side that is connected. So side AC would be my adjacent, which would make BC my opposite. And this diagonal side is still going to be the hypotenuse. Alright, so hopefully that's a little bit of an introductory vocab for you to get you started in case you were able to finish earlier. And hopefully you will get to your worksheet, which is due tomorrow, or homework.